Oh, can you see the dongle?
See?
The dongle, the thing, USB. Oh, it's here.
Yeah, yeah.
You want to do it? Okay. It's time, right? You can reach to? Sorry? You can reach to? Yes, fine.
Hello. Can you hear me? Yeah. Can you hear me now? Okay. Tarek, are you in the room?
Let's give everyone 1 more minute to sit down.
We'll get started in a couple of minutes. I like that. I would like that.
Yeah. That's right. Boss chairs his last meeting.
Take a picture, please.
No, it's a good idea.
Can you sit in the
Your last chairing gig.
Last chair gig, so why not? Should I do with glasses or without?
I'm going to do one with flash, one without. 1, 2. Flash? Oh, there we go. All right, 1.
Oh, wait a minute. You got to do the flash again because it probably off glasses is not good.
Actually, I want to do this one. You ready? I'm going to do the flash again, too. All right, so 1, 2. George, come over here so you get the name in the background. You get the working group name. All right, one last time. 1, 2, flash. Yeah. All right.
It's like another one.
Twice. So, Lo, I'll get out of your way. You just want a picture of the last time, in theory.
For those of you wondering what's happening up here, you'll notice that this is actually a joint MPLS working group. So this will officially be Ross's last working group that he's chairing. So we wanted to sort of note that. We really appreciate all the time that you've spent with us. Thank you, individually and as a community.
Thank you. Yeah, you can pass them on.
Are we ready to start? Do you have any note? Well, can you display that?
Yeah. Can I just do a few slides?
Huh?
Well,
Yeah, it's up there. Okay. So this is the joint meeting between MPLS, TEAS, and PCE, discussing Yang models with an interest for at least two of the groups at the same time, or sometimes all three. If you wonder why some of the chairs kind of scramble up to the front and sit down here, that's because if you are sharing sitting in the audience, you have to take notes. That's a period there. You have to take some type of notes. Do Etherpad if you can. The exception is Ross, because this is his last meeting. He don't have to do it. Also, we count on working group chairs available to do some type of note taking. So we should have a good note taking. You have the note well on the board on the screen. If you haven't read it, take a few minutes to read it before you start talking or contributing to the meeting. It's important information. So
as well as note takers, could we have a volunteer to be a Jabber scribe? Thanks, Lou. Thanks, Julian. So here is our agenda. We had a fairly relaxed agenda, but it suddenly grew in the last 5 minutes. So it would be really good if we could leave a little time at the end for an additional presentation that wasn't published ahead of time on LSP Ping Yang. Greg, I hope Greg's arrived in the room. Well, he has until the end of the meeting to get here. And anyone want to bash the agenda? No, it's good. Okay. So the first presenter is Zufeng.
there's the steering wheel.
Good afternoon. I'm Xufeng Liu from Ericsson, reporting the progress of the Yang data model for T topologies on behalf of the authors and the contributors listed here. We have two sessions for this. In the morning, we had a brief 20-minute session to discuss some specific topics here. And so here in this session, I will do a general progress report and skip some of the details of the discussions. Okay. Yeah. Yeah, this is a summary of changes since the last revision. We did the reorganization of the draft. We added the support for several features, including multi-layer topology support, protection on the tunnel termination point, label restrictions on connectivity matrix, and topology optimization options, and also inter-domain topology support. Next, please. So about the reorganization of the draft. So we moved some shared types into IETF types YANG module. And this is because we have a type shared with the TE model. So we move to the type module so that we can have both modules to share the same type. And also we moved one YANG module used to be in this draft, which is an extension for the packet switching. So we moved that module, IETF technology topology PIC, into the layer 3 T topology draft. We have more to introduce that later on. We also did the extension to the T topology model to cover segment routing topology, so that we can compute the SR route. And we submit the separate draft for that, so we'll have more later on. Next slide, please. So we talk a little bit more on each of the features. So this is for the multi-layer topology support. We discussed in last IETF, so we added the support. In the model, we added the switching capability and encoding type to the tunnel termination point. The purpose of that is to support the transitional link. Next slide, please. This shows how do we use that additional attributes. We have some link can be marked as a transitional link, and at each endpoint of the transitional link, we may have two different kind of layers. So this picture shows that. Next slide, please. If we don't want to split the node, as we showed in previous slide, we can use the interlayer lock ID. So we add that attribute in the model. Next slide. So that purpose is to group related tunnel termination point and the link termination point, so that we know what kind of adaptation capability we can have. Next slide, please. Then other feature is the tunnel termination point. We will have the protection type specified, so that we can support the different kind of tunnel protection. Next time. Next slide. Also, we added this is based on the feedback we got for the model. So we added the label restriction on the connectivity matrix. This picture shows what kind of restriction we can have, because for each connectivity matrix items, some connections may not support all the labels, so we can specify some label range. So in that above labels, the box shows that the link between RTP5 to RTP1 will support those 5 labels. The other one will support any label, but not the range from 100 to 199. Next, please. And the model implementation will be, we add a section to the connectivity matrix, so we can achieve any particular label or a list of label or a label range. Next slide. We also added the support for the topology optimization options. So that's one attribute, so that we can ask the provider, so what kind of optimization criteria we want to use. Next slide. And this is one topic we discussed in the morning, so I won't go to details. So the purpose of this feature is to connect multiple domains from the provider topology and merge them together into the client's native topology. So at the bottom, we have two domains from two providers, and then at the top, the client can merge them together. Next slide, please. Right, so here shows a different kind of client, the provider abstractions. Next slide. Then we can have a different kind of merging. Next slide. This is a modeling transformation implication. We added the several attributes here. We will have a remote T, node ID, link ID, and all plug ID. So next slide. So here is an example. How do we use the T node ID and the T link ID? Next slide. And here's an example to use the plug ID. Next slide. We had some debate talk about what time we should use, so probably we'll skip this next time. Next slide. Next slide. And then the next step will continue, get the further reviews, and we have to-do list. So we are pretty much close to be done, and we'll get more review comments and address some issues we have, and then I think that we can have that pretty much completed, and the model currently is more or less stable now. Next slide. Yeah, so this is another draft we talked about. So we taking out some of the non-generic portion of the model into the layer 3 T topologies. Next slide. So this draft only deal with the layer 3 T topology. And to achieve layer 3 T topology, we have one augmentation to the current existing I2S IETF layer 3 topology. That's left side here. And then we also have augmentation to the TE topology to add the packet specific attributes. So that's the right side augmentation. We had some discussion about the naming. So based on the discussion in the morning, so we changed the name from TE topology PIC to packet. And the relationship between the non-TE portion of the model and the TE topology instances, that we have the leaf ref between the two topology models, so that we can model the association relations. Next slide. Yes, here's how the model augments. So we added the leaf ref we described in the previous page. Next slide, please. And here's the augmentation to the base T topology at the packet specific augmentations. Next slide. So this model is pretty simple. So we ask for further review and for the work group adoption. Next slide. Then another extension to the TE topology model would be to have the model to support the path computation for the segment routing. Next slide, please. For this one, we're also working with the ISR, there's another Yang model called the ISR segment routing Yang model. And here, this model, we augment also the layer 3 unicast IGP topology model. From there, we add those ISR specific attributes. Next slide, please. So particularly, we currently already have for the network wide, we will have sRGB. Next slide, please. And for each node, we have some per node specific attribute like sRGB and the capabilities and some states. So next slide. And also we added we use the link to model the adjacency SR ID, so that for each link we'll have some link specific SR attribute here. Next slide, please. So all those things, the SR related attribute, most of them coming from the SR Yang model. So we'll need to, so that's the relationship between the SR topology model and the, that SR topology model augment from layer 3 unicast topology model. But when we do, how do we achieve the SRTE? So for this one, we'll have multiple inheritance. So any SRT topology instance will have a topology type, both L3TE and SR. So fortunately, the topology types allow us to do this so that we can have such kind of topology instance. So that diagram shows the relationship. Next slide, please. We mentioned that we're working with the Spring people to reuse some of the groupings and types defined in the model, but currently we cannot directly import the model yet. So the next step will be work with them to rework that model so that we can have a shared model to have the same set of attributes. And some other features for SR is not completed, so like protection on the link and bundle. Next slide, please. Oh, we don't have any, so we're done.
Hello, Dhruv from Huawei. What is the relationship that you are thinking between the two models, SR Yang? Can we go to the slide?
Which two models?
The last slide? Yeah. Because there's so many models, it's better to point.
Pointer's not working.
Last model slide. Actually, next step.
Next slide.
Can you do slide?
Yeah.
Okay, I see what you're saying. So
this model, what is the relationship we have never showed? Is it only we are going to share the groupings, or would there be?
This model is the device model, the SR Sprint Yang model. That's on the one single device. Only give you the attribute you needed on that particular node. There's no global picture. You cannot do path computation on that. And so our model is like a global view of that. You can use on the controller. You can do the path computation on that.
Yeah, the ask for them is to see if they can have a separate types module that can be in here.
Yeah.
So just the types you will share.
Yeah, because we have a similar kind of attributes. We need to share the types. So we need to work with them to have those model restructured.
The part that I was a little bit confused about was the config part, because we are doing almost the same config on the device, there. And now you are saying that this is a generic model that you can use it at the controller. So would I be also doing, for example, sRGB configuration on each node by going to the controller? No, right? So why it's read, write, and in this model?
Rewrite this node.
If you can just go.
Okay.
Third, yeah, just
Which slide do you want?
Go back to the.
this whole thing where we are going to the node and adding the attributes. So, and it's read write. So that part, I was not sure why we are doing this.
Hi, this is Tarek. I'm a co-author on this. So there are cases where links and nodes are learned using an IGP agent or BGP or whatever protocol. But there are cases where you would like to provision a link statically injected in the topology. And in that case, you need write access. And in that case, you need to set the attributes statically. So this is why we have the read write, the write basically.
Just a bit of guideline, just a bit of guidelines when there's a conflict, what do we do? The thing is, like in the Yang models, we are just put these things, we need a little bit more description so that when we read, we don't get confused what is happening. Otherwise, very good work is needed. I agree that that is just a device model, this is something else, but the relationship part, so that we can understand that better. Thank you.
Yeah, sure.
You're Bruce Huawei. One of my clients actually expressed an interest in combined layer 2 and T topology, so that he can do also path computation based on layer 2 reachability and T as well. Okay, so we might think doing something like that as well.
We talk. So we are done.
Yeah.
No question? Okay.
Thanks. Tarek. Quick questions to the audience on the previous presentation. There were a couple of individual drafts apart from the base T topology module that were presented. How many of you have read these drafts? Yeah, not a lot. Yeah, these are fairly. Yeah, please do go through the modules and send in your comments to the list. Thanks.
Okay, am I set to go? Okay. Hi, everyone. My name is Tarek Saad, and this is a repeat of the presentation we've done in the morning. And basically, it's an update on draft defining the Yang model for TE tunnels and interfaces. I'm presenting on the behalf of the co-authors listed there, and thank you. In the morning, we did talk about the open issues. In this presentation, I will go deeper into the updates that we've done since the previous revision. And I'll still go over the open issues and give an update from the morning because I was able to sync up with one of the Yang doctors. So since the previous revision, we've introduced a new module to describe segment routing traffic engineering augmentation to the TE model, the generic TE model. With this, we are able now to set a signaling type on per path of the tunnel. And the signaling type can be segment routing or RGPTE. So that's the path signaling type. We've added as well a couple of constraints that are specific to segment routing computation, path computation. Namely, with respect to picking the adjacency segment, there is an option to pick a protected or unprotected. And we also now are able to specify the path as a set of labels as opposed to the ERO set of IP addresses, for example. The second update, we are introducing a way to connect a link, a TE link, with a hierarchical, with an LSP that's used to signal the underlay LSP or tunnel. For this, within the tunnel context, tunnel attributes, we are adding a set of data parameters to identify the link in the topology that is associated with this tunnel. And basically, it's a set of IDs, node ID, local and remote, and the local termination point ID, as well as the specific topology we're talking about. So with this, we can associate a specific TE-link with an underlay tunnel. And if there are any attributes associated, collected with the tunnel, we can send them to the TE-link. Third update is we are introducing a generalized label of type binary with no strict type check on the size of this label. We still will use the technology-specific labels, namely the MPLS and any other technology. And these technology labels will be used by the technology models, of course, associated with them. But there are those models that are containing multiple technologies in them. And this is where the generic label will be used. And if we need to do some additional type checking on those, we will do some runtime type check with a must, Yang must keyword. The last update we've done, basically there is an interest to define a TE transport service model. And they're thinking of extending the model that we're driving to do that. And the team that is driving that reviewed our model and they gave us some feedback. We're working on addressing their concerns. Namely, some of them were mentioned already by Shufeng. The use of UREs instead of strings or uints. And there are some RPC requirements that we talked about with them. And we mentioned probably in the morning. And I'll go through them again today. So in terms of issues, the first one, and again, we talked about it in the morning. Maybe I'll go over this quicker now. The issue is to how do we reuse the generic model for the multiple technologies that we have. Obviously, we don't want to repeat the same data elements in every technology, so maximize reusability. One way to do that is to define groupings. And once we have generic groupings, then we can augment the grouping within the context of the module that the technology module. So this is an example where MPLS is the technology module. We're using the generic and augmenting it with MPLS specific. Another example is for OTN. We're still using the generic and we're augmenting it with OTN. Now, this is one way. It has some advantages. It has disadvantages. And I'm leaving them here. But at the end, I will summarize and maybe we can see them in a better shape. The second option we had to solve this is to use this mounting capability, that mount schema capability. It's been standardized at IETF. Again, it has some advantages and disadvantages. I will summarize at the end. And the third option to address that reuse of model for different technologies is to have one model and mix all the technologies in it, and have in every data node a way to say that this data node is MPLS or OTN or that technology, basically. And in terms of listing all the options that we have with a summary of capabilities that we will achieve with each, with option 1 grouping, we have the capability to reuse the generic data. We cannot augment. So we have an issue when we're trying to reference from one node to another node in the in different groupings. With the grouping approach, you can have the separation of technology models. And lastly, we cannot augment until we use the grouping, and that's has negative implications. So the second option, which is the mount schema approach, it gives you the reuse of generic data. I cannot I cannot point to a leaf defined outside the mount tree, so it worked. So it does give us the separation, but and it does give us the augmentation capability to the generic model. So it has quite a few of check marks associated with some drawback here. And the third option will give us the reusability of generic data. We can do leaf wraps between nodes in different groupings. We cannot achieve the separation because all of the technology nodes are in one list. And yes, it does the augmentation of the generic model. So I did approach one of the Yang doctors and I went over the options, and they did acknowledge that these are the options possible. Now, they are under the capability of addressing that limitation in the mount schema approach is under investigation. They asked me to send an email. I did, and I'll wait for their feedback. All of the options at the moment are of equal preference to us. So that's the update on that discussion. I see Lou wanted to ask a question, so I'll pause.
Sorry.
No problem.
Lou Berger, a little slow to the mic. Did you send that? Did you send that to the individual or to the list?
Yang doctors list. Copied these as well.
Okay. It would be good to send that to NetMod and say that you have a requirement for this, and that it's the case. There's two different schema mount cases, one where you sort of mount anything and one where you mount something specific. Mm-hmm. So it'd be good to be clear that you're talking about the case of mounting a single thing.
Yeah.
And in fact, if you can go into the mount draft and copy and paste the semantics that you would want to use.
Sure. Okay.
That would actually be really helpful. And it may be that, we just relax the restriction in that case.
Okay. I'll do that.
Thanks.
Go ahead.
Hi, Xian from Huawei. I don't have a strong opinion on options, but I wonder whether the discussion applied to the TE tunnel model also applied to the topology, because I think the topology has already going through with option 3. Well, we have a network type. You can augment by saying whether it's a layer 1 topology, or it's a layer 0 topology, or it's a layer 3 topology.
So, yeah, I guess your question is about the previous model that Chufeng was.
I think they're related, so
They are related. I admit that. To my knowledge, is the routing model, the routing config based model. They're taking a mount approach. I might be not accurate on this, but probably I'm right. So they are taking that approach, option number 2, to address the capability of attaching a model at certain layer. So I'm hoping that somebody will respond and say that this was tripped on and they have a solution for it.
That's Lou Berger again. The routing config is using it, but it's using that other form. Mm-hmm. So there's I think of it as a wild card, mount anything. And that form is being used in the routing document, as well as the routing working groups, 2 documents for a logical network element and network instance. Mm-hmm. That's the wild card mount. Yep. From the design team standpoint, we saw the need elsewhere, which is why we asked for the other form that you're using. So I think you're actually going to be the first user.
Yeah.
We actually thought BGP was going to be the first user, but okay.
Sure. Okay. All right. So this is a figure that shows the models that we've been working on and their relationship with each other. And within the context of amount, it's taken from the previous presentation that we've given in Buenos Aires. It's basically for illustration. I'm giving it here. We did introduce the segment routing traffic engineering module. It was grayed out before. Now it's defined. The second issue I wanted to talk about, and we did address it in the morning, we agreed to have separation of point-to-point, point-to-multipoint, and point-to-point tunnels in different lists. So that gives us a cleaner way to list both. We did talk about the RPCs and how we could use them. One idea was we could use the RPC to create tunnels, and that will be an ephemeral state. We agreed in the morning that that might not be a good idea, so we will discard this for now. In terms of next steps, we will try to conclude on the open issues. We request further reviews and we will try to address the comments. We wanted to sync up about the PCCTE data model with PCC/PCE Yang implementers or designers. So that's about it. I'm hoping I didn't go over the allotted time.
So, can you go back to slide update 2 and 3?
Update, okay. System.
Here is, I need the mic. You have the labels listed somewhere.
Oh, yeah, the labels. Here.
There, okay. So here you have MPLS labels 0 to 20 bits. Is it really possible to configure the special purpose labels, or at least all of them, because some of them are only control plane? And if you actually configure the extension label, what would that mean? So there is an issue they need to sort out on the first 16, I think.
I'll try to answer that. So yeah, in here we're trying to define the type of the label and the valid range. And yes, when you want to instantiate a specific label value, you want to set, it's possible that you want to set a restriction on what's acceptable for that instantiation. And yes, and I agree, in that case, we will need additional checks, but not on the type,
Not on the type.
on the instantiation itself.
Okay. So update number 2. Here you mention, let's see, you had TP somewhere. Is that on the
Termination point, I guess, this one.
Yeah. So when I looked at this one, I had a real problem. If there are more people than me that have problem with TP and thinks it's transport profile, this TP is actually topology. So I would, for clarification, actually suggest you add an L or something in the name. Then I don't remember. I go check. I have one thing more.
Lou Berger, following up on Lois. Can you go back one slide? How do you do the, I'm sorry, the one that had the labels on it. Yeah, how do you do the extension labels?
Maybe not.
Is extension labels in the sense,
So these are like special purpose, but we have bigger values.
okay,
So beyond the
the
first
16, the 15, 16. Okay.
Yes, I'm sorry, value 15.
They still fall in the range, right?
You basically have two labels. So
Oh, I
if you
see.
had a type and then that label field, it would work, and you'd set the type to 15. That would be a solution. I mean, there's lots, or you'd have to give 2 labels.
Okay, I have to admit, I didn't think about that, and I can get back to you on how
Yeah, I
we
didn't-
think we'll address this.
I have to say, I didn't think about it at all until Lola raised this question.
Okay.
Dhruv from Huawei. So regarding the PCCT model, yes, I would request if we can, from the start, if we can work together
Okay.
and figure it out. Because I'm still not sure exactly what we will put in that model. Because if we keep PCEP as a generic thing, and another issue could be that if this is PCC only when it is a device, but in case of when we are doing hierarchy PCE or when we are doing multi-domain, a PCE can also be a PCC in the terms of the PCEP. So we have to be very careful of what we are saying here. So we can work together on that.
Sure.
And the second point was, there was from the last meeting or on the mailing list, we had one discussion regarding LSP state key. So what is the key for our LSP? It's 5 tuple plus, I think, type. So we had this discussion whether for other signaling type like SR and now the new work that we are doing in PC-based central controller, are we happy with that key for any type that we come up with in future? Personally, I am. So I wanted to make sure that authors and SR authors and everybody agrees on that.
So yes, this is what we're still using as a key, except that we agreed to split the point to multi-point from point to point. So the type will go from that key, and because we have 2 separate lists now.
So,
But I'm just stating what we have now. We're still going with that.
okay,
Correct
I
assumption.
am happy with that. Thank you.
All right, thanks, Dhruv.
So, Tarek,
Yeah.
you have a slide called T/RSVP and MPLS Young models. The one where you have the overview of
Structure.
the structure. That one. I don't need to have that. So I'm thinking about the IETF Yang, the one on the top, that actually are inheriting from 2 different other models. Is there a problem about naming things in the 2 models that is inherited from? And do we need to make sure that we have ADs and others aware of that we need a special type of review when we actually do things like this?
So the purpose of the figure here is to show that I'm mounting the same model under different base models. In this case, it's MPLS. I'm mounting the TE generic model, and then possibly another OTN, and then the same one will be mounted. In this case, there will not be a clash of namespace at all, and it's not inheritance. This is what I want to mention, that it's mounting.
Yeah.
I'm trying to mount, not
But
inherit.
you had another picture where you actually did the inheritance.
Yeah, probably.
You inherited 2 different.
Yeah, there are cases where we're doing multiple imports.
Yeah.
But Yang itself has a a prefix associated when you import with the module, so there will be no collision in that case.
Okay. Thank you for the
No problem.
tutorial.
No, that's okay. All right. The next, yeah, please. All right. The next update is about the base MPLS and the static MPLS LSP models. Again, I'm presenting on the behalf of the co-authors here. A little bit of background. So the base MPLS and static base MPLS is basically augmenting the routing config model. We have a reference to it here. It defines the MPLS types and the MPLS interface list. And it's expected that it'll be augmented by other MPLS capable modules. The static LSP MPLS module it's a way to provision and manage static LSPs that are point-to-point, point-to-multipoint, and multi-point to multi-point as well. And our mandate is also to cover unidirectional and bidirectional LSPs. In terms of update for the static LSP models, since the last previous revision, we did introduce the capability to allocate bandwidth or set bandwidth on per static LSP, as well as the priority in an extended module. We did define the bidirectional static LSP properties. Work in progress is still ongoing in terms of the modeling of multi-point to multi-point and point-to-multipoint static LSPs. We are considering the case where make before break could be happening for static LSPs as well, and the case for end-to-end path protection. We did introduce a new fact mappings. I will show you on the figure in the next slide, basically what we've done. So this is the base MPLS model. Again, it's just for illustration here. We are importing the routing module and the interface module, and this is the MPLS type is being defined in the base, as I mentioned. The MPLS container here and hanging from routing, and we have the interface list. I'm happy to answer questions. Basically simple. In terms of static MPLS LSP model, as it stands now, this is how it looks. I hope you can see that. It's not that legible, but we've introduced a new fact mapping for tunnel and MPLS label at the ingress, and possibly some new properties as well. Again, it's importing from the multiple modules up above. Okay, so this is the extended static LSP model. This is something new that we introduced in this revision. In here, we are defining the capability to set the bandwidth on a specific LSP, the priority, and we also are able now to define bidirectional LSPs. The way it's a list of bidirectional LSPs keyed by name, and the way we're modeling the bidirectional LSPs is having a pointer for the forward LSP and reverse LSP pointing in the list of LSPs, and the ones that we have them in the previous slide. So this is how we realize bidirectional LSPs basically. In terms of open issues, again, we have this issue of reusing the same model for different technologies. It's the same topic that I talked about in the previous presentation. So we need, once we agree on something and or a resolution for the issue, then we have to apply it here as well. So again, I'm listing the options, but we went over them in the previous presentation. Next steps. We wanted to conclude on the point-to-point and multi-point to multi-point static LSPs, make before break, and end-to-end path protection. We want to close on the approach, of course, of reuse for multiple technologies, and we are soliciting more review and comments from the working group.
Iftikhar, Infinera. Quick question: what do you mean by protection of the static LSP here? Iftikhar, Infinera.
Yeah.
Okay. So
yeah.
So you get the question. Yeah.
So, yeah, I heard the question.
I mean, because what does it mean for a
right.
static? Yeah.
Right. So the idea is to be able to statically provision a working and a standby LSP and associate them on the ingress and egress points.
But I mean, how about so who's taking care of the coordination switchovers, where's, that machinery? Is it like linear protection? What is it? Yeah, that's the question.
So the idea is that you provision as a user statically two LSPs, one for the working and one for the standby, and they're both associated in such a way that if a failure is hit on the working, a pre-programmed standby is at the ingress.
How the two ends know, okay, I need to switch over?
Right. So that's a good question. So there has to be capability in the forwarding plane to do that.
I'm saying it's from the modeling perspective. I'm just asking in the context of the modeling. Do you need to have some other things to define in order to actually fully describe this case?
So Iftikhar, this is an open item that we want. It's open for discussion at the moment. We haven't modeled it yet. But that's a good point that you're raising, and we will make sure that enough discussion happens on it.
Lou Berger, what have you done, or what is your thinking about the whole open config discussion, and open config applied state discussion?
Yeah.
Sorry to open that can of worms.
No, yeah. So far we've tried to abide by the open config as much as possible in defining our models, and it's a heavy process. It introduces a lot of mechanical work that we have to do. It's probably useful for some operators. I'm not going to argue about the utility of it or not, but it appears that we don't have consensus in the IETF about its usage, and I'm not sure. Maybe I'm mistaken, but the recommendation is to retire this open config way of doing things.
Right. Absolutely. The recommendation is don't go through that heavyweight process because it's too heavyweight and too easy to get wrong. So don't do it. But it also recognizes the fact that some models are far enough along, it doesn't make sense to rewind.
That's right.
Where do you think these stand?
For the static LSP model, I think it's in a good state that, we'd like to keep it unless somebody is not happy with it.
I think we have to treat it as a set. I think it would be really weird to have some of our models one way and the other part that built on top of those another way.
I hate to say, but it's true. We have to be consistent and somehow,
So the recommendation that we heard yesterday from in routing working group that's likely to be passed around the routing area is going to be you shouldn't do it, shouldn't refactor, but if you have it and the working group really wants to go forward with it, do it as a augmentation, which is a bit of a change also.
It's a bit of a change, yes.
Yeah, but it doesn't change your baseline structure. It's just factoring out a whole bunch of leaves and it's separating it.
Yeah.
As authors, what do you think? Do you think it makes sense to go the augmentation route or just go back and simplify and not worry about this whole problem?
As a single author, I'd like to concentrate on completing the model and then come back to this.
Okay.
But maybe other co-authors have different opinions. I'm just speaking on my behalf.
Pawan Biran, Juniper Networks, speaking as a co-author. I would like to keep it consistent across all the RCPT, MPLS basic models. The reason why we did the open config way was that we had the hope that at some point they would reuse our groupings. I don't see that happening at this point. So either way is fine, but we would like to keep it consistent. I would like to keep it consistent.
Yeah. Given where we are in the process, I sort of feel like simplifying our models might be nice. And that's said with any hat you want to pick. But I think it's also important to hear from the room. So maybe we should ask what others think.
I see a couple of other authors behind.
Cool.
Kamran, Cisco Systems. As a co-author for Amplistatic, I agree with both Tariq and and Vishnu, Pawan. And for LDP and MLDP, as an author, I think we also have some similar discussion, and we like to keep it consistent with all other MPLS working group document. And we wanted to also simplify. We have some provision for open config, but we are partially compliant. So I think we are, at this point in time, we're thinking to basically remove that and be consistent with all the MPLS topics.
So your preference is to remove?
Yes.
Xifeng Liu from Ericsson. In terms of the amount of work to restructure, I say it's a much heavier work to change the structure from the previous net mode structure to open config structure. But if you reverse that direction, actually it's not that much work. So we simply remove the container and change the one grouping. We can still keep the grouping, and so should be not that much work. And beyond that, there are another implication. So which is not just the implied configuration state, that's the derived state. That's where we may or may want to reconsider, have a simplified structure. That's a wider implication, and probably will introduce some work.
Yeah, on the true operational state, and the example I always use is counters. There's flexibility, and it's basically make an informed choice. So there's nothing simple there for the simplifying thing for the model authors. It's, you got to do it smartly. So unfortunately, there's work there. What I heard from the comments was, let's be consistent. Most people didn't care, and there's one person who had I think I only heard one person leaning to strip it out and to simplify. Personally, again, I like the simplify thing. Do we want to hear from the room, see if anyone has opinion?
Hello, can I kind of interject a question maybe to you? So would it actually work if you actually have both the simplified and the more complicated model, and you actually inherit from modules that actually have one each? Would the...
If you assume we're at the end state where we have the revised data store-based solution to applied, and we have models that have been augmented to have leaves that do the same thing, it just means double the work for the guys writing the servers. They have to get to the same piece of information two different ways. So it would work. It's just more work, more implementation load. And the reason also to do it as an augmentation is that that augmentation, if someone new comes along and they're going to do an implementation, they wouldn't do the augmentation. They just throw away the augmentation. They would just do the base, which is laid out to allow for that open config style, those open config style leaves, but they wouldn't have to go implement two paths to the same piece of information. So it does hang together. It's just really complex. And if my description of having two paths to the same piece of information sounds complex, think of coding that and maybe coding it for 100 or 1,000 leaves, and those aren't like crazy numbers, right? So if we have two different ways, it's a lot of extra work, and that's really beyond having models that are easier to read, which some people care about. I don't. Programs read it. I don't. But beyond it being easier to read and simpler, and are having documents that are shorter in length, which is all goodness, it's just less code.
Agree. So actually then I would like to take my chair hat off and actually state an opinion here. I would actually want to go for the simplified across the board.
Can I put a chair hat on and ask the room?
Yeah. Yeah.
Okay. I think I want to ask this three ways. And the guys in the front will say how the response is. I can't see them at all. How many people care about this? Less than I would expect at a Yang session. But still.
Yeah.
Oh, by the way.
Like 20?
How many like the simplified approach?
Same.
Say what you see, because I can't see.
Basically the same.
All right, I hear basically the same. How many would like to maintain the open config approach, where we have a convention-based approach?
With or without the augmentation? With or without the augmentation?
So as is or without?
As is or with
With augmentation.
with augmentation?
With augmentation. So I didn't ask the third one. You want me to ask the third? I'll ask the third one. Who would like it as is, which is going to go against the recommendation of the routing area, but sure, we can ask that. So keep it as is. So we have one person who likes that. Do you want to hear why, or should we move on? How are we on time?
We have time.
5 minutes.
okay.
Do you want to say anything? Okay. All right, thank you.
Thanks.
Next. Who's next?
Sure.
Shen, you're next.
Yeah. You have the, yeah.
Hi everyone, my name is Shen from Huawei. I'm presenting the draft, the service AI model for transport networks on behalf of the authors and contributors. And so this is not a new draft. Actually, we presented last time in CCamp because the network space we're looking at is where we implement the model is in the connection-oriented transport networks. Examples can be OTN, WDM, MPLS-TP. And so the objective, if we look at the use case, this diagram. Okay, so what we're looking at is the interface on the transport controller, which actually control the transport network. And we are exposing a RESTful interface, so that a client, in our example, will be an orchestrator, can have an API. They can do like service creation, service deletion, and service update. And so I expand the diagram a bit, which the orchestrator itself facing a northbound client portal, for example, maybe a DCN provider or a data center provider. Well, they can ask for a connectivity from, in this case, DC1 to DC2 to carry a example like 1 gigabit Ethernet traffic service. And so this point may hit the point the network provider to the customer interface. Well, the observer is talking about the service model, but here we are looking at particularly this interface. So I later will go through a very simple example where we're showing how to use the model, but I want first to look at the service model itself as well as giving a bit of open discussion. So here is a quick look at the model itself. It's overall, it looks pretty generic. It's not really tied up with OTN or WDM. It has a service ID and also a list of endpoints where you can also specify the service type like P2P, P2MP, and P2MP. And if the orchestrator itself is given the information of what tunnel is available, it can specify what the server layer tunnel they want. And the bandwidth, the protocol type is the basic elements. What we have from a customer is they also want to have a way to have kind of like schedule bandwidth demand, which means they can ask for service, but not immediate now, actually at a later point of time. So we reuse the schedule attributes defined by another module. And also last piece is the constraints, where the customer may want a service smaller than certain milliseconds, and also maybe it can want where we put in objective is I want a service with the least delay as possible. I didn't show the state part. Well, it duplicates almost all this plus the operational state. And so here I give a big picture where we show that this service model is actually one of the models we are looking at. If you look at IETF YAM models, it doesn't really tell you which interface is going to be used. But in our case, we are specifically looking at the interface between the orchestrator and the transport domain controller. So here you can see that we have a topology where we have the ODU and WDM topology. We also have tunnel model where you have ODU tunnel and OCH tunnel. Here I call it layer 0 and layer 1. So last time we presented CCamp, we already got a comment from TE Tunnel also say why not reuse the TE Tunnel YAM model. We look at the models, but we still fail on the other side. So we still like, the reasons I put here is the most important one is not often. First reason is I think the concept is different because for the service, it's really what the client cares. They may not care about, whether it's you do CSPF or you do dynamic. It's just wanting something where I can use for my service. So the demarcation, the service starting end on the client operator demarcation point. So for example, UNI to be the simplest case. But well, the tunnel, I think at the moment in its current form is actually modeling as an entity starting from a TTP to a TTP. That's the first reason. The second one is we agree the T tunnel is needed, but we think they are actually allowing for two different behaviors. The first one is a client can ask for a service where they only specify the parameter state care, and this can driven the domain, in our case, the transport controller, to create multiple tunnels just to cater this specific need. On the other hand, we also have the case where the orchestrator, if they have the information, they can actually pre-plan the resource usage. Like, for example, I don't have any service requests. I still can plan to set up ODU tunnel or OCH tunnel, which can be later used by a specific request. Other differences which I list, most important one is, I think tunnel for transport network is based P2P and P2MP, but for service, they can be more than that. For example, the MP2MP in the case. Here, I come back to example where I showed before. Here, we assumption that is actually the client as well as orchestrator may not have enough information about the actual topology, so it's like a black box to them. And what the service request is, they want to have from DC1 to DC2 have a connectivity where they can send the 1 gigabit Ethernet traffic over. So using that model we've described before, you can see here the orchestrator can send to the transport controller using that model which defined, which says is set up a service from NE5 TP1 to NE3 TP1. And that signal type is 1 gigabit Ethernet, and the service type is P2P. Upon receiving this request, the transport controller needs to set up, for example, in our case, is 10G ODU tunnel. Well, the tunnel is between something internal to the device from one TTP in NE5 to another TTP in NE3. And the second step will be you need to choose the time slots where it's going to wrap the gigabit Ethernet traffic into ODU. And once this is done, assuming it's successful created, then the transport controller will send a reply with the service created to the orchestrator. So here we didn't show, well, you can pre-plan ODU2, the 10 gig ODU2 here. So another point is that the service type, because the model we wrote is actually intend to cover both OTN client service as well as Ethernet service. So we plan to augment on top of that to add the specific attributes. Tarek, you want to ask?
Yes. Tarek Francisco. Can Can you clarify if in step 2, you mean you could use the TE tunnel module to create your tunnel, or you're thinking of using a new model to do that? And if you are going to use a new model, I still don't understand what's missing in the existing model, and why can't we augment?
Step 2.1 or step 1?
2?
Step 2. Actually, in our case, we don't actually use any YAM models anymore because that's the southbound between that's the control between the controller device. We actually use PSAP to create a tunnel.
Okay.
So it's the mountain. But if you want, you can still use the tunnel model.
I'm confused a bit. So, what are you modeling here?
Sorry.
You're modeling what? What number 1?
Here. So
you're modeling step number 1?
yes.
Okay, so maybe you need to clarify then. Okay, so it's the service. Okay. Okay, so no need to talk about okay, tunnel creation. I got confused. That's all. And thanks.
Okay. Okay. So this comes to the final slide. There are open issues. We already received comments from mailing list saying why use integer 32 for the service ID. I think that's more general to other modules as well. So we will follow up once there's a consensus. So we'd like people to review this and give us feedbacks in terms of whether such work is useful, because we do have a multi-party interest. But look at the model, it's maybe wider than just transport. So we will really like to hear your opinion about this.
Daniele Ceccarelli. I would like to ask a question, mostly for clarification. So the service, is the service something that you build on top of a tunnel?
I would say the other way. Service will be carried by the pipe. I mean the tunnel.
Okay. Yeah, it's the same thing. So, is there anything technology specific in the service, or everything that is technology specific is in the tunnel only? Or both?
At the moment, I think we don't have, for example, for the Ethernet service, I don't see we actually model the information like a big information rate in here in IETF.
Okay, I was thinking, for example, consider, I don't know, an OTN service. It will be a service that uses an OTN pipe, an OTN tunnel.
Yeah.
So everything that is technology specific is in the tunnel. Is there anything that is OTN specific in the service too, or nothing at all?
I would expect there are a couple of attributes that will be a specific example. The example I have here, the signal type, this is actually particular to OTN service model. Yeah.
So we agree that both the tunnel and the service have something technology specific.
Yes, I was saying that. Yeah.
So Anurag Sharma from Infinera. I think this service can also be created using the tunnel model which Tariq has, because Tariq over there, he has 2 options for the CSPA. One is with ERO and one is dynamic. So I think your use case is more of dynamic, where you send the request down to the NE to kind of create, like get a path. So essentially providing the 2 ends and then asking the NE to kind of find the path. It might be possible.
We've investigated. We checked actually we are participating weekly in the TE tunnel meeting, and I think especially maybe on this point it's a big blur, but if we look at here, there's no way, how to say, if I approach a client and say, this is the API I'm going to provide to you, but I see a lot of attributes which is optional, but actually it's never going to be used. It's not as clean as it is. So it will, if I do use it, it's going to be an awkward situation where providing a YAM model itself is not sufficient. I need to put an additional document saying this is not needed, and actually its service is not tunnel. So we still fail to have a different model.
Himanshu Shah from Siena. So I have about the same question as he does. In my view, the service is it's a layer 2 VPN service or layer 3 VPN service that you are going to run over the tunnel. It's not something that you want to say specific about the tunnel at the orchestrator level. You have to abstract that out, right? So whether you are going to create a pseudo wire or whether you are going to provide an IP service.
So I think we agree that there's a layer 3 VPN service model, layer 2 VPN service model. So to some extent, the simplest form will be the point-to-point connectivity service model. So I know it comes to the point where it's blurred because it's actually related to tunnel. So
yeah.
I'm
confused about the validity of this because this L3SM and there is I guess there is a layer 2 service also model that is being worked upon, and I see that as a service rather than this doing with specific to the optical pipe or anything like that. You don't want that at that level between the orchestrator and the STM controller.
I think there's some confusion. Maybe the ultimate in that service. So I think there's two different concepts going around, and I don't know how they all glue together. But there's the Ethernet service up here, and it needs a bunch of pipes, perhaps if it's a VPN. And then that service has to request those pipes as a service from the OTN network. So there's really two layers of service in my mind.
Right, that could be hierarchical service, but I don't know whether that is exposed all the way to the orchestrator or not.
So I think, Himanshu, I think that this is about having a transport as a service. So the service that's being provisioned is not the end user service. It's kind of a client layer within the ODU, where ODU you can have server layers and client layers. And the client layer is really there to set up a pipe over which you can carry an end user service. It's not the actual service that you're giving to the end user.
Okay, I guess we need some other document to connect all the dots as far as all different type and hierarchical services are concerned, right?
Well, actually, I partially agree with you, but what you say is incomplete in my opinion, because it's true that we can have higher layer services on top of a pipe, but we can have services as big as the pipe, in the sense that you can sell an OTN service, you can sell a WDM service without anything on top. Then the part I agree with is that I don't think we have a common service model. We have the L3SM, we have the service model for layer 2, but we don't have an umbrella that is collecting all the services together. I'm looking at you, but maybe it's not a question for you. It's
we look at it a bit differently. Actually, we're looking at specifically. So as I said, we are target the special network space where we can have the Ethernet service, or we can have the OTN client service. So I agree that Ethernet service can be carried over. Maybe connection is a network, but I don't know how to. Maybe so that's where the service model may be applicable to a wider context. I don't know.
Yeah. Yep. So I don't know. Do we have something in mind to solve this? I don't know. Connection-oriented services all under the same umbrella. TE services all under the same umbrella. Non-TE services, who cares? Something like that. You're planning to cover all the TE services here, so transport and non-transport services?
No, the intention is only cover transport. But if we have people with non-transport background, we can work together to have a common one.
So this is something good, but we need more.
Yeah.
Last question from Igor.
Okay, my question actually to George. Okay, so basically what you said is that you set up first OTN tunnel, okay, and then on top of that, you are setting, for example, Ethernet point-to-point service, right? So can you say that you also, on top of that, you're setting up end-to-end tunnel, Ethernet tunnel? Okay, so the question is basically, again, comes down to what is the difference between, say, tunnel and the service and transport service, right? So we can say that, for example, tunnel could be started on customer side, on a network, and so is service. Service could be with schedules, and so could be tunnel, right? So basically, that's what I keep saying, that I fail to see the difference, and there is no difference. Then basically, why not to use the tunnel model?
I understand point. We have discussed a lot about this, but I can come up with an example where the client signal is actually STM16, so there's no the tunnel per se. Yeah.
John, before you go, can you go to the start slide?
Mm-hmm.
And one more back.
That's it. It's the first slide.
One more. Good.
Oh, this way.
Okay, that's fine.
Dhruv.
Thank you. Hi, this is Dhruv from Huawei, and on behalf of my co-authors, this is PCEP Yang, and update to the PCEP Yang since we last presented in the joint session. Basically, this is the Yang for a PCEP speaker. You are managing the config and the state that you need to manage the PCEP protocol. It's initially was based on 5440. It was aligned to our existing PCEP MIB. And in the recent revisions, we have been working on adding the stateful PCE, segment routing, other RFCs like SPEC, objective functions, global optimization, and a little bit of P2MP as well. So what are the changes that we made since the last update? We had a discussion where we showed how the reference to the LSP state in T model would be maintained. So we have made that change. We added support for PC initiated LSP. So I will show you what that change looked like. Segment routing, authentication, including PCEP over TLS and PCEP S draft, and association between LSPs, which PCE has created in the LSP state, of course. So inside the PCEP state, this we discussed last time that we will have LSPDB in the state, and within LSPDB, we are maintaining the reference to the T state model of all the 5 tuples. And once the type change happens, the same change will happen here as well. So this is just a reference to the T state. We are not maintaining any of the T parameters which are already defined in this model. So for any property of this LSP, you need to go to the LSP state in the T model and try to get this information. So this, since the T model is generic, that it can exist on both device and controller, this would work, and it will work at the PCC level as well as at the PCE level. Then for PC initiated, what we need to change was add the capability. So a local entity would have a capability. It will enable with PC initiated that I have a PC initiated capability, and based on that, in my open message, I will make sure that I carry the flag. Same information can be configured on a per peer basis as well. So that's the only thing that we need in this model. Actual tunnel properties will definitely not go in this model. That remains in the T model where you create the tunnel. So similarly, in the LSP state, I would like to know the LSPs which were actually initiated by a PCE and not configured locally. So that information in a flag is maintained, and also a reference to which PCE that created this LSP. If I have that information, that also I can maintain. And then changes are related to statistics because we have a new message. So stats related to those message in the PCEP protocol. Segment routing. For segment routing, again, clear change, just a capability. I have a SR capability. I have to configure as an entity, as well as at the peer level, this configuration can be made. So that's all. We need only the capability. Everything else goes in the SRT Yang model. MSD is there. This also we plan to move. It should not be a configuration or information stored in the PCEP. It should be referred in the Yang model. So SR Yang model. So we will make that change in the next revision. So basically, that's all we need to change in PCEP. For authentication between PCEP speaker, here we refer to the keychain which has been used in other protocol, so that we can use the same concept. So we have the keychain model, and we are using various types. So you have a support for keychain or a particular key, as well as the algorithm. So which in PCEP we care for MD5. So MD5 is included. But I would like to get a feedback. Is it better to keep it aligned? And though none of our PCEP documents talk about using any of the other algorithm, but we felt that it's better to keep it aligned with the other things that we are doing in the IETF and let the option still be there, though it may or may not be actually enabled. So the thing that we added new, which was not there in the other keychain, is the TLS. So this is still work in progress. We need to add more parameters. How do we configure TLS and other information that we need to pass it on there. So that is the pending part with respect to authentication. Is that authentication question?
Yeah, so it's not question, it's comment. So since keychain is done routing working group, we are ready for last call, so it's stable and
can you
keychain?
Yeah.
It's stable and it will go into last call soon.
Oh,
next week.
yeah. So I'm using the same as it is. So this is in PCEP, we have something called as an association. So this is a generic association object where you can maintain in your LSP state how are the LSPs relate to each other. The most common use case is protection. So here we are maintaining in our LSP state the association which a PC may be carrying in its own protocol. So it needs to maintain that state somewhere. So we have the association type, association ID, source, global, other things. So the two way we are maintaining this association is you have an association list globally and you list all the LSPs that belongs to this association, as well as when you are an LSP, you maintain all the association that you belong to. Because according to our association generic object, we allow multiple association, and within an association, again, you can have multiple LSP. And this is quite generic. It's not just for one type like protection. For actual protection parameters, we will still refer to the TE model where actual what kind of protection, what is happening, those details will still be maintained. This is just the relationship between set of LSPs within the PCE database. So the thing that from PCEP point of view, the thing that we would need the TE Yang model to provide is when you are configuring the tunnel on the device, marking that those tunnels needs to be delegated to a PCE. So this may belong in the IETF TE PCC model what Tariq showed in his document, or it could belong in the basic IETF TE device. So we can work out the details where to put this information. The second information would be that if you are configuring the tunnel at the controller, do I need to say that this tunnel needs to be initiated via PCEP protocol? And again, we feel that this belongs somewhere in the TE Yang model, and we'll have discussions and figure it out where to put this information there. So basically from our side, we have still some pending issues with the features that we have added. For example, authentication, we need to figure the TCP/A part, TLS. So we will clean up that. This, I'm going to keep it pending. Let's see how the discussion goes. I will wait for TE authors to figure it out, what decisions they have taken, and then only I will touch rearrangement if we do. And finally, the work has been quite stable. We have updated, added new features. So we would hope that we could adopt this work so that we can continue on it. Any questions?
Okay, so Julien, I don't know if you want to. handle the adoption. So I'm a co-author of this, and obviously this isn't the official poll for adoption. We will do that on the mailing list, and Julian, I think will handle that.
If you prefer. Would you like to see who read this document? Yes.
So I see about 15 hands.
Okay. Who believe this could be a foundation for PC working group item? Almost the
15,
same.
yeah.
Yeah. More. Who believe this should not be used as a foundation for a working group item? None. So I think we have consensus in the room at least, and we'll send a poll over the PC meeting list pretty soon.
Thank you.
You're welcome. Thank you.
Who's next, Cameron? Cameron, you are next.
Hello, everyone. My name is Kamran. Work for Cisco Systems. I'm presenting this update for LDP MLDP Yang data model on behalf of other co-authors listed on this page, plus some other contributors. So a bit of history to the revisions. So we have been presenting this draft from IETF 92 and all the IETF since then. So this is our revision 4 we just posted before Berlin. Main things in this revision 4 is about that it addresses, sorry, it went back to, it addresses the MPLS RT review comments. MPLS review RT process was started on this draft in May, and there were 4 reviewers. They did a wonderful job. We got some useful comments, and we addressed in our revision 4, which was posted just before this ITF. So main changes in revision 4 that this revision basically addressed is realigned with some of the things in MPLS base, as well as things that's happening in routing working group on a routing config and a network instance model. So we rearranged our Yang tree accordingly. Now we augment off routing as a control plane protocol under routing. This is our model, and this is as per recommendation from device model that all routing protocol, including LDP and RSVPT, have to augment control plane protocols under routing. We addressed almost all, not all, almost all of the MPLS RT review comments. The one which are not addressed there, none of them is blocking, and we plan to address them after this document is adopted. We also, so this document from the day one was for both LDP and MLDP, and we have 4 sections on each of them. One for configuration, other for state, RPC, and notification. So only pending action, only pending main work that was before this revision was MLDP operational state. So this revision 4 also addresses and adds LDP operational state. We also clarified some of the semantic of the peer. One GR has to be considered. This was a comment from last ITF. There's some text that has been added to clarify in the document. We also added an open action item section, and we have a new author now. So coming to MPLS RT comments, we already replied on the list. Some of them are still open, but I think main thing is that no blocking issues were raised by any of MPLS RT reviewers, and they think the document is ready for working group adoption. We thank MPLS RT team for doing a wonderful review and give us very useful comments. It helped us a lot. So just going with some of the main comments from some reviewers. So there was the comment on the dependency on the op state in netmod, and we were well aware of that, and we are keeping our document up to date as well as according to the guideline that we received in this ITF. We'll update once more. There were comments about, a couple of comments from different reviewers about that we have to reuse existing defined data types rather than redefining ours, and we already addressed in this revision. Yeah, one comment which is, I think we are still evaluating, is that there are lots of features and objects in this model. Yeah, we are trying to cover a base LDP, base MLDP, and some of the core LDP and MLDP RFC. So I guess this is 2 protocols we are trying to address, and the model is becoming complex in sense of number of objects and the features we are trying to handle. But we are still evaluating, and we'll try to see what we can trim down and cut down in next revision. Yeah, so there was also an important comment that we said that it's only addresses platform specific label space, whereas for so platform specific label space, but there was a comment if we are supporting upstream label allocation as well as a capability for LDP, then we have to also support context specific label space. That comment was addressed in this revision. And there were a couple of comments on independent order mode. One of them is still open. Right, there's two other comments I want to highlight here is that one suggestion was to break this into base and extended parts. I think this goes along back with the comment, this has lots of features. So maybe the base features, base model should have a very simple base things, and the extended should have other feature set. So we are evaluating that. We will get back to it before next revision. Another suggestion was to have MLDP into its own module. We discussed this in the very first IETF with the working group, and agreement was to keep them in the same document at that point in time and also same module. Having said that, module is becoming pretty significant now, so we might consider breaking to its own module, and but we will evaluate that and we'll get back to on this this comment in before next IETF. We are yeah, and then right, so there was also other comments about use of enum and user existing things. That all of them have been addressed in this revision. We have not specified any default values. Any default values that RFC specifies, we will address in our next revision. Right now, we have just not defining any default values for the configuration items. And we also addressed the comments from Mac about Yang validation check and some augmentation path. So this was MPL's RT review comments specific update. The other update we made was for MLDP operational state. So there are mainly two things we added. One was a root database, another was for MLDP multi-point bindings in our model. So just without going into much detail, basically this just shows how our MLDP root database looks like. It is per address family, you're right, and what we are presenting in a root is basically reachability to a root. It does not specify bindings or LSP at this point in time. It just shows that how a root is reachable through what next hop, and whether this next hop has an LDP peer, because it's possible that you have a root reachability without any LDP peer running or operational on a given path. So for example, if we think this is a visually, this is how it will look like. For a given route, you might have multi-path reachability. There's information coming from RIB, and there's information related to LDP peer. For MLDP binding, so this, we try to align this the way we define LDP bindings, so that fact label bindings and have our advertised bindings versus received binding. We try to model MLDP binding on the same along the same lines. However, one thing we have to, of course, do an additional about MLDP binding, that MLDP fact defines opaque types. So we could have kept them opaque, but that will not be very useful on an operational state point of view. So we also now define, we try to expose opaque types. So we have defined bindings for opaque types. And there are three major categories of opaque type we are handling. One from base LDP model, 6388, one from in-band signaling in WRF and without WRF, and other is recursive fact. So this model handles all these opaque types, which are defined in these three RFCs. So I will not go into lots of detail here, but what I want to highlight here is that the binding really that we see from peer, right, is advertised or received side, and it could be an upstream or downstream direction. So upstream and downstream in our draft really means upstream and downstream from the point of view of the root location. Because for MP to MP case, upstream downstream becomes confusing. So this but then this is the same terminology we're using for LDP. So these are all the opaque type we are defining and we are exposing in our operational state model. As I said, but there are three main types, which is LSPID based opaque type, source, and bidirectional. And then you have their variants, VPN variant or recursive fact variant. Right. So the example, as an example, For example, a P2MP binding would look like you have an upstream advertisement and you have received advertisement from downstream. So you have a remote label learn or you have advertised your local label. This model exactly like LDP binding. However, for MP2MP, right, you have upstream. Okay, actually, MP2MP is the next one. For MP2MP, you advertise in both direction, upstream and downstream, and you receive from both direction. So it's very similar. In addition to that, we also kept provision for specifying protection state. In MLDP, when advertise, you could be advertising binding for MBB, make before break reasons, or MFRR. So it also displays in the binding section whether a binding is for MBB reasons or MFRR reason, and if it is for those protection reasons, what is the role of this particular binding? Is it active or standby, or MFRR active or backup? Right. So, and we also added an open item section in our draft. Right now, these are the items which are still pending. First item, I think we already had a discussion that we have to align or realign with regards to this op-state decision that is done in this IETF. And we already have agreed that we'll probably simplify our model to remove what we have so far. We were partially compliant with OpenConfig anyways, so we are not fully compliant. Second, main thing we have to address post this IETF is to specify default values for RFC defined configuration parameters, which is not there yet for LDP and MLDP. Try to cut down on the scope and number of features in the document. We are evaluating, we'll see what we can do. And possibly, and that this bullet goes with the previous bullet, try to split model into base and extended. Base, just keeping the very base, and extended, keeping all the bells and whistles and different features. And add some counters and statistics for MLDP LSPs. So next step, we're asking for working group adoption, and while we were in IETF, so we have working group adoption has been initiated. Thank you, Chairs and Tariq. So people who haven't read the draft, please go ahead and see if document is ready for working group adoption. And post IETF, we will also address rest of the MPLS-RT comments, and hopefully we'll close all the comments with the MPLS-RT reviewers to make sure that we haven't missed any. Any questions? Okay. Right. Thank you.
So the rest of the meeting belongs to Greg.
Nothing is free. Okay, the work can start, and state of art. The data model includes target FAQ and target FAQ type, reply mode, source address. So it's a basic 4379. I think that's very good, fortunate, well, though it's a long time due, to finish this work because of the work being done in MPLS group on a BIS document, which clarifies, so basically removes absolute DS map, adds DD map, and does some other clarifications. The current model includes a schedule configuration and read-only for the operational state. So what we briefly talked with authors, and the future work probably would be align scope with this 4379 BIS. The question mark whether to address 7110, which is a directed response. Since we include schedule, and actually I heard that there is another model that uses schedule, it might be interesting to look at measurement agent Yang model in LMAP group, which does use a schedule for the measurements. So there might be some commonality and some reuse. And at the same time, so to use this model in MPLS-TP OEM model, MPLS modem, and as well the common OEM model, which is worked by line working group. And next logical steps would be obviously working group adoption, and we always welcome your review, comments, and suggestions. That's all. Free drinks.
Sorry, just a quick question. Italo Busi. When you generalize this model, when I look at, for example, BSTP OEM, are you considering a concept like MEG, MAP, and MIP, or which are very generic, or are we going to be more protocol specific?
But LSP ping does not differentiate MAP and MIP. If we are talking about
That's
trace
my
route,
question. Yeah. So how do you want to target this?
No, but again, for example, in MPLS, MAP and MIP only exist in as a terminology in MPLS-TP architecture.
Yep.
And even in MPLS-TP architecture, that is realized, if we're talking about levels, through SPME,
Yep.
right? Then it would be just LSP ping over this hierarchical LSP.
Yeah, I understand. I just trying to understand how do you make it generic to be applicable to all these
Well,
different
again,
concepts. Okay, we can.
But
It's just
there
that
was
it's
no,
difficult for me.
okay, there was no intention to introduce or use MAP and MIP terminology in LSP ping, because for LSP ping, it's always about target FAC. If you want to use for trace route, then you set TTL.
Michael from Huawei. As a LAN co-author, I want to clarify some questions. First, the LAN is split two modules. One is connection-oriented OEM, another is connect-less OEM. In connected OEM, it not defines map and the MIP. This structures is augment topology module and to build the relationship with different touch point. So I think you perhaps you can review the list version. Okay, thank you.
Mm-hmm. Okay, well, thank you. Okay, that's the end of our meeting. Thanks to all our scribes and speakers and chairs. See you in South Korea.
I'd like 10, 15 minutes.